Dmitry, and I am glad to be here. I'm glad to be a part of the organization team and help to organize this beautiful event. And I am New Goose, by the way, and I'm not. It's not my profile picture. Just making sure. But in general, saying me. So I have never been working in OCaml industry as a paid worker. I've been always doing this stuff in other languages, and now I am systems engineer, whatever it's called, or low-level programmer. I don't know how to qualify it. So I write mostly Rust, C, now Zig, and other languages, but I still love OCaml. And you probably maybe know me by this project. This used to be the fastest in the world project for image comparison libraries. Interesting, you cannot see the red dots, but the red dots should identify the different pixels. So this project is used by a lot of visual regression services to implement this stuff in, should I stay here? I don't know, whatever. So, and this project used to be the fastest in the world and written in OCaml. And last conference, I made a talk about the story of this project, all the optimizations. But today, I'm going to make it a little bit disappointed talk. And I don't want this talk to look like I am trying to disappoint you or Jason Street. That's what I'm trying to do. But basically, OCaml, the odiff is not written in OCaml anymore. It's written in Zig for a few reasons. I'm going to tell you a story, and then I tried to kind of combine all of this knowledge to make a good overview of OxCaml. So generally saying, in the start of this year, I've got a side hustle or whatever it's called. So the company came to me that is using odiff, and they use some AI-generated slop, and they wanted to build OCaml and run it on mobile. They use React Native, and they wanted odiff so much to run on OCaml, and I for sure agreed to help them. And then I regretted this decision because I spent like 3 days compiling OCaml projects to Android with the C libraries, and I was like, I'm sorry. And that was very, very exciting times because Cloud Code came, and I just translated odiff sources to another language, and then we built everything up. They were satisfied, realized that on mobiles, FPU units are much slower than we used to think, so we rewritten the algorithm to eliminate all the floating point operation at all, and it became really fast and was really nice. But I thought that I will release this project soon enough for everyone, rewritten in another language, but I didn't for a few months. And when I've been working on this presentation, because I used to, we as an organizer team, we needed a talk about OxCaml, and I will call it OxCaml because 0xCaml is I don't know, my mouth is not able to pronounce it correctly. So that would be OxCaml. I wanted to make the project, the comparison. So I rewritten it again in Zig, and here is why. So basically, to compare it with OCaml, we really need to have all the targets supported. So I had an issue to compile it to FreeBSD for 4 years and to ARM Windows for 2 years. And I just couldn't do this because OCaml cross-compilation is really bad. There is no SIMD support, which makes it 70-150% slower on whatever it could be, because in Zig I implemented the SIMD first algorithm. There is no public API possibility, which is one of the biggest problems for mobile support, because I need a C API to be able to link for other languages. Now we use and share binary. We used to share binary over NPM because that was our larger consumers, but that is not available on every platform. And the binary size. The binary size in OCaml v5 is really, really big. And I actually think I lied here because it's 4x smaller. We used to have 50 megabytes package with 4 binaries, and now it's like 10 or something like this. But it seems like a beautiful thing to solve using OxCaml. Don't you think about this? Because OxCaml is shared like something, the OCaml for people who are interested in performance, that gives you control over the implementation and over the way it allocates memory. It does that SIMD support, and I was really interested. When it appeared, I was like, oh my god, that seems to be a good solution. Maybe I can use it. And unfortunately, I couldn't because of the support of basically binaries cross-compilation. But I just want to make a sure and big note that OxCaml is still in development stage. So more platforms and most of these solutions will likely be, most of the issues will likely be fixed. But I think it's still interesting to compare how OxCaml works on the platforms right now. And to compare the performance as systems engineer standpoint, we can try to compile a simple Fibonacci function with one single record to see how it works on OCaml v4 and OCaml v5. And let's compile it. You cannot read assembly in this slide. I did. So this is OxCaml code. You can see that it doesn't allocate anything, so caml call GC is not called here. And it's like, generally saying, pretty concise and pretty good assembly. But then let's compile it with OCaml v4. Like, there is no difference. It's the same assembly. And it was confusing, because when I started learning and doing this comparison, I was like, what the heck? Okay, but I figured it out. Then let's compile it with Zig. And the Zig solution is much smaller and much faster, and the binary size is like 50 kilobytes versus a megabyte for OxCaml, which is a huge deal for performance and for portability. So let's figure out what's going on. So I tried to also compile odiff code, so I couldn't compile odiff because of C dependencies and C world with OxCaml completely, but I did compile the algorithm, and again, there is no difference. And I was like, okay, I probably need to start reading documentation. And I was like, I thought maybe I'm wrong, and maybe their support for ARM, because I'm a huge ARM fan, is limited. So I got a spare x86 machine, and like this is how my life looks like because I'm moving. So I had plenty of time to work around and investigate how OxCaml works on Linux and Darwin, which are two supported platforms so far on both ARM and x86, and I figured it out. And the first thing that you need to realize about OxCaml that this is not a new language. This is not a new OCaml. This is an extension. So I actually caught a Jane Street employee here in this conference, and they said to me that they run everything with OxCaml today. And this is kind of impressive. And to understand that this is like 100% backward compatibility. So you can run your existing code with OxCaml, and it will continue working as before. And this is actually beautiful. I really appreciate it. But how we can actually verify what is new in the OxCaml? So there are a few things they're trying to solve. And the first one is the stack allocations. And OCaml used to be known for a slower code than than all of the systems programming languages, or like C, Rust, or whatever, and even then Go, because it used to allocate a lot of stuff. Every record, if it escapes the local region, it used to be allocated on the heap, which is slow. So let's try to figure out how we can see the actual difference. So I wrote a simple example with a Fibonacci kind of function that is transferring not an int, but a record. So you can see here that basically we just pass a Fibonacci function into the record, and I think this should be a recursive function, but you can imagine that this is a recursive Fibonacci calculation, and on every iteration we return a new record. In this case, normal OCaml, standard OCaml, will basically compile to something like this. Here you can see this is an assembly, and here in the bottom you can see 3 calls for caml call GC, meaning that this function allocates at least 3 times, because allocations could be batched. And this case, this is the part where the record is created. You can see that the allocated memory getting stored onto the like this store and str gets loaded into the memory and the heap, and then it's getting like loaded again and return the actual the actual pointer to the heap value. And when you do this in a recursive function, you can see that like every single iteration will do a new heap allocation, which makes no sense because we know exactly the size of this two floats, or it's even integers. You don't even need like to think about this. And this is can be catched in OCaml. So here in OxCaml. So in OxCaml, the first thing that you probably will figure out is the new directives for locals, for modes that allow you to verify and enforce stack allocation for the certain things. So if you will add a new stack underscore to the allocation of this returning record, you will actually get a compiler validation. It will say, I'm sorry, you requested us to do the stack allocation here, but we can't because it escapes its region. Do something about it. What we can do, and we can do something really interesting. So OxCaml does have a new type for all the records and all basically primitives. So floats of different sizes, ints, and so on and so forth. And it looks like hashed symbol plus something. So in this case, we can define our record as with a hash before and do all the access using hashes and return it using hashes. And this actually makes a lot of difference. So here is the assembly for this code. This is an assembly, and what you can see that exactly there is no heap allocations at all. And this is huge because this like roughly eliminated like I calculated it, it was roughly 5 million instructions for large Fibonacci calculations, which is really nice. And I think this is one of the biggest issues Jane Street tried to address because they run a huge cloud. And for the some performance issues, you can just like go to the existing OCaml function that just works like you expected and add a few hashtags, and it just becomes faster. And this is kind of beautiful, and I think it's like really good that you can just incrementally adopt it in the other languages. Why is this a problem? So please raise your hand if you have ever needed to deal with stack allocations and like different allocations problems in OCaml at least. Okay. Not much people. Great. I'll be more descriptive. So the problem is very simple. That when you have some layout like option of some record with a float inside, and this value is not getting optimized by normal OCaml locality optimizations, how the memory will be structured. You will have an option which will have a pointer, basically C pointer, to some other option that is getting again a pointer to some other record in the memory, and then and it contains floats, which is also a pointer to the float value. OCaml has a specific optimization for only float records, but if you have float and something else like int, it will be pointer. So in order to get this 17.4, which we exactly know the size of, you need to do 1, 2, 3, 4 instructions to load the data in the memory. And this could become slower. This is becoming really slow because the stack is usually allocated on the stack pointer is allocated either in the start on the end of the memory space addresses, and the stack is mostly always on L0 cache in every programming language. This is not true about OCaml minor heap. So this load could become really slow. It's not that invisible, but sometimes it could become a problem. So what we can do now, we can do something like this. We can have an option which is a simple pointer. It could be a pointer to a stack as well. And then you have one single memory space where you store all the data, and if you need a pointer to a string, it will be a pointer, which is basically the same layout as you will see in Rust. If you will the option of type in Rust, your memory layout will be exactly the same. This is possible because the new layout for the memories, for the values. So historically, OCaml never had an ability to store nullable pointers in the values. So every value should have been guaranteed to have a value inside. Now, with OxCaml, we do have a new built-in option type, which is basically null or this. And I very much hope this was getting merged to the OCaml code because this is so good. You can now, if you have head and tail functions for the lists, and you can see this 1L is a new syntax for the int64 raw representations of ints. You have a list of the raw ints, and you have a head function, and here is how it's compiled into assembly. It's beauty. It is just like a few instructions, basically 2 instructions. It just takes the pointer and gets the first element of the pointer. Here is how the normal OCaml looks like. It's also unboxed, but because OCaml cannot hold the pointer that is nullable, you need to raise an exception. Now you can skip it at all and have all the option basically be managed as a pointer, as a nullable pointer, without any additional problems. And this is so cool. I really wished I could have that when I've been working on odiff, because I used to have a lot of optimization to be past this specific limitation. Oh, sorry. And the problem is, can you just use it? Can I just take my existing OCaml code and use this new option? No, you can't. Again, because it's a giant street and this is the corporate event, and I'm not judging them, but I think the biggest boost for productivity you will get if you have a ton of existing OCaml code, which is sometimes slow, and you can just incrementally optimize it. Because writing the code from scratch for everything for the new OCaml or rewriting the existing code is kind of really annoying. So I got back and tried to implement the new odiff algorithm. So basically, I just took the existing odiff algorithm and implemented it with the new OxCaml raw floats. It became faster, and the assembly became really good. But this is becoming really annoying because I basically need to rewrite everything. I just can't compile the existing odiff code with OxCaml. And they have this module float. This is the sources from OxCaml sources itself. And this is just weird because, I don't know, it used to be all the history, all 27 years of OCaml, you used to write plus dot. And for some reason, OxCaml decided that you just can use pluses for the unwrapped floats. So it makes sense, but for me, it makes more sense to have plus hash or something like this. But this is really nice. And basically, just one more thing about this rewrite, you cannot mix existing floats and the new unwrapped floats. So you will always get all of this types. So it says then this expression has type float, but an expression was expected of type value or null. And this is becoming sometimes really annoying because you need to change all of the possible mentions of any float literals, and then in other places break in and you need to go there and fix it there, or you duplicate your constants. But I think it's works of the new language that has just popped out. And wow, there is nothing here. Okay, so here is the chart. So I compiled odiff with the new OxCaml and run it against Zik. And here is what I've seen. I was like, what the heck? It's, again, much slower. This is, again, I don't understand what's going on. So here is another thing. I realized that Zig is doing a lot of auto-vectorization code by default. So I somehow turned off the Zig's optimization for the auto-vectorization, and which brought OxCaml code basically on a parity with the Zig code. It's still kind of slower, and I think more of because some quirks of specifically ARM support in OxCaml, but it's much impressive. It's really impressive because it used to be much slower. So, talking about auto-vectorization, SIMD. SIMD is a huge thing in the new systems programming world, and I'm really glad that OCaml OxCaml is bringing this into the functional programming world, and I really love SIMD programming. SIMD, in short, this is a single instruction, multiple data. So in assembly and instruction world, you have an ability to write a few, let's say integers into a certain instruction, and then you run one single add instruction, and it adds everything into the OxCaml. And all the time, mostly all of the history of C world, it used to be solved using auto-vectorization. So SIMD in the C world, mostly always associated with you write the same code and your compiler somehow optimizes this into vectorization. The problem that it usually fails, so you cannot rely on this, but it can do this for you. OxCaml doesn't have it at all. So in OxCaml, you never get the auto-vectorization code. Despite I found /d vectorize function, and I've seen a few source files that seems to be doing this, it seems like not being enabled right now. So currently, the only way of using SIMD instruction in OxCaml is the intrinsics. And this is basically how add arrays in SIMD will look like. You have a new library that exposes certain intrinsics for different layouts. So in this case, we do 2 times float64, and there is only one supported architecture. It's Linux, and this, no, it's not Linux, it's basically x64 with SSE2. And this is kind of, I have a mixed feeling about this, because this code looks like very much like C. Because for me, OCaml was always more about like expressiveness. And when you do something like this in a functional programming language, I don't know, it looks weird to me a little bit. But maybe it makes sense to optimize a certain flows that are specifically working slow in your cloud, one single function, and keep it understandable for all of the other, for all the folks that are writing OCaml in your company. That probably makes sense. But again, how would you deal the conditional compilation? Because this doesn't work on ARM at all, and you will not even able to compile it on ARM if you use this intrinsics. And the assembly generated is really okay. So we'll spend a lot of time on this, but it actually uses assembly intrinsics. It uses raw values, because these intrinsics are basically caught by the compiler itself and getting intercepted and emitted as assembly instructions. So there could be no additional boxing or additional problems with them. If you use them, they are really efficient and really nice. And this is kind of good. The one thing that I don't really understand is this tweet by Yaron Minsky saying that OxCaml will not provide a portable SIMD instruction. And this, for me, makes totally no sense, because, and I hope he's wrong, because I found this source code for the portable SIMD with OxCaml, with the latest preview version, that seems to be doing exactly that. And I really expect them to maybe change their opinion, because I feel like abstraction over SIMD is actually where the future is, because no one wants to write different intrinsics. And in case like if you work on code base like FFmpeg, you just like, yeah, it makes sense to write assembly functions with specifically targeting architectures. But when you write functional programming code with a high-level declarativity and piping operators, so for me, I don't really understand what is the point of having intrinsics in OCaml. But if they will bring a good abstraction type, a good abstraction for SIMD, like for example in Zig, they will be huge. So here is a SIMD done cross-platform in odiff, and this code basically takes 2 SIMD-sized vectors from the list and then compares them independently. So for example, for AVX512 platform, we can have 512 bytes of ints and compare them using one single instruction. And then if it's positive case, which is 90% of our comparisons, we just skip a lot of incrementations as well. This is improving the performance on some platforms by 200%, like 170% I've seen, but I'm not exactly sure if I measured it correctly. So if this will be possible in OxCaml, it will be huge. And there is a new project that seems to be appeared right in time when I released OCaml odiff rewritten in Zig, called VxDiff. And this is basically entirely rewritten odiff into assembly, into AVX512 assembly. And it's kind of huge. And the weirdest part, that the person who written this is now here in the room. Where are you? Yeah, here's the dude who made me embarrassed right now, because they were written faster than the fastest in the world. So I had to get this promotion down, but I did this a little bit before. But that's really nice, and I feel like this is a good shout out for Sir Pen776. Follow them on Twitter. He does a lot of nice things and seems to be really smart. And maybe we will steal your code to become again the fastest in the world. So, and the last problem that usually systems programming engineers solve is portability. So when you write things in assembly, it is not portable at all. If you write things in Zig or C, it is portable to every single platform. And OCaml, generally saying, is not really portable language. I don't have any more slides, so give me a few minutes, please, if it's possible. You can see slides, right? It's not. Okay. Okay, great. Portability. So the problem with portability is that now with Zig Original Camel, thanks to Shreyas contribution, we can basically, with a single Zig toolchain, we can compile to every single platform, to FreeBSD, to everything. We don't even need a VC package or CMake. We don't even need anything about like to merge it, to compile odiff to FreeBSD to some weird ARM 32 bits platforms used by Android. And I need to merge this PR, but also a giant shout out to Shreyas that basically this is huge. But this is not, I think, out of scope for OxCaml, because portability is not the question for Jane Street, because they are likely not compile the stuff for the other platforms. But the other thing, I'll try to be very fast on this, is fearless concurrency and safety. And this is basically the new thing for parallel programming that is basically the first language in production, I think, in industry that does allow fearless concurrency for parallelism except Rust. And this works really, really fun. So this is a new code with the new capsules, which are new mutexes and other stuff, and schedulers that allow you to prevent data races. Because OCaml is memory safe, but not data race safe. You can always mutate the pointer, the reference from the other thread, and get the data race. But then with the new modes, contended, shared, and portable, and uncontended, you can now write things like this. So here is a simple image ML module, very quickly, that has this new annotation for the contended and shared pointers. And now, for the things like this, where we can say this is just a pseudocode, it's actual code for grayscale difference of images, you can go and write the function that is doing something within the code, right? So in this case, just getting the sibling pixels and comparing them and storing the total diff somewhere. And then you can write the code, for example, like this code that is getting called here. You can see brightness diff at within the capsule, within the scheduler inside the capsule key. I'm trying to be fast to not slow down the conference. But now, like, let's say you have this fearless concurrency brightness diff at, and now you add a new random dumb ref here, right? So somebody just found this function and thought it's a good idea to have somewhere a ref that is going to be captured in the argument and then it incremented. Now you will get compile time error that this is not possible. And this used to be only a case with Rust, which allows you to share the mutable state across their mutability and ownership model. But now with odiff, you can also do this using these modes, and this is really huge because this solves a giant problem. Yeah, this is really nice, and I really appreciate it. And the question, do we need a faster OCaml? Yes, we do. And I really hope that OxCaml, most of the stuff like raw integers, somehow migrate into the normal OCaml and becomes the default, as this will bring OCaml into the world where it would be. I hope it will be faster than Go. We need to. That's my dream. That's my dream to piece off Go developers. But basically, this is the idea, and this is the overview for OxCaml. Thank you.
Thank you, Dmitry. Is there any question? All the way back.
Thank you very much. It was extremely interesting. I have a question which is not really related to the talk, but what is your insight comparing expressivity between Zig and OCaml? Because it looks very verbose and very complicated.
Sorry, you mean expressivity of what?
Of writing code.
The code.
Yeah.
So the code. So Gerald was saying, right? I feel like so there is two different things. The imperative programming and functional programming are totally different. And I really love functional programming for expressiveness. But like I'm also used to imperative programming. I write code in Z, in C, in Zig, in Rust, and like in JavaScript and a bunch of other nonsense languages like Go. So this is like, I mean, I'm okay with that. The problem that usually like Zig code is definitely more bloated than OCaml code, that's for sure. And I find it less beautiful myself, but the beauty is a very subjective feeling, right? So
yeah, it's a perfect subjective answer. Thank you very much.
Is there any other question? Cool. Thank. Oh,
there was
wait.
There was one. Yeah.
Don't doubt. Just ask the question.
Cheers. Thanks for an interesting talk. I have a quick one about, so you mentioned about portability of SIMD. So just out of interest, when you're working on odiff and wanted to keep SIMD portable, is another case that the compiler might mess up across different targets and you need to keep adding some sort of, keep messing with the code a little bit, so on a specific target it works better. Is that something that you face, or do you actually think that this is not a problem and you can have portable SIMD?
Yes. So yeah, I want to be clear on this. I really love writing assembly, and I am writing assembly in the raw assembly files. And when you do stuff like, for example, in FFmpeg, there is a function that compares RGB to YUQ color space, and this code is getting executed like billions times during this talk because like it's like we're everywhere on YouTube. Please write this code in assembly because your compiler will mess the things up, and like instruction level efficiency is important if you write Linux. But when I write the code in odiff, which is getting executed like much smaller amount of time, I can ignore an ability to like a single cache miss. Because as well, I would love to write everything in AVX assembly like Serpent 776 does, but I just don't have resources to support all the platforms, and I don't have infinite amount of time. So I think Vix portable assembly, which is basically a layer on top of LLVM's portable assembly, which is also used by OxCaml, and it could be used because OxCaml has LLVMize module, which is not used for everything, but for something, it could be adopted. And I think it is good enough in current state. Sometimes it will be less efficient, but when you keep looking into assembly and you see your assembly, I've been testing it out, looking into the ARM assembly, it's good. It's okay.
Cool, thanks.
Perfect. So yeah, thank you, Dmitry.
Okay.
Great talk.
Thanks.